let's go over a really important topic in mathematics, algebra specifically, slope of a line. Slope is very commonly written as the letter m, and it's defined as the following. It's the change in your y-coordinates divided by the change in your x-coordinates. A lot of times you'll see this written different ways. Some include this way. You might hear a teacher or someone say slope is equal to rise over run. And I like to use the symbolic notation of delta y over delta x. So that little triangle is called delta. It's a Greek letter, and we use delta to signify change, and we use this throughout other courses, math and science alike. So delta y just means what's the change in your y values, and delta x just means what's the change in your x values. So if you're given a graph of 2 points, which I have here on the left, 2, 6 and 5, 11, the easiest way to think about this graphically is just find the vertical distance between the points and the horizontal distance. So if I were to draw a vertical line and a horizontal line to get from the point on the left to get to the point on the right, it would look something like this. So from here, we have to travel upwards, and I'll switch colors here, and then we travel over to the right. So in green there, I would say that that's my delta y. And in brown, going horizontally, I would say that's my delta x. Okay, well, if I rewrite my formula again, m, slope, is my delta y over my delta x. Well, y is a positive distance, right? Because I'm traveling upwards. So let's count here. It's be from this point, we're going up 1, 2, 3, 4, 5. So that's a positive distance of 5. And we travel to the right, which on the x-axis, that's a positive distance as well, positive direction, 1, 2, 3. So the slope of this line containing those 2 points is 5 over 3. And we can leave that as a fraction. The most common way you'll see them written is as a fraction. Sometimes you might write it as a decimal or a whole number, but a fraction usually makes the most sense because since it's defined as a ratio of 2 things, the y-coordinate change and the x-coordinate change, writing it as a fraction is very nice because you can instantly talk about what the numerator means and the denominator means. Let's look at an example where we're going to find the slope of a line that contains 2 given points. And my 2 points are -2, 2 and 4, -2. So if you do have a graph available, you can always just go ahead and graph the points. So to start out, let's just do that. Let's go ahead and see what it looks like if I graph the points. So -2, 2 means you go left 2, up 2, right? My x, y, so that's -2, 2. And then 4, -2, you go right 4 and then down 2. Right, so this is my -2, 2 point, just to make sure. And this is my 4, -2. So let's find the distance between these 2 points. More specifically, the vertical distance and the horizontal distance. So if you notice, to get from the point on the left to the point on the right, we do have to travel downwards. So that's my delta y. And then we travel horizontally to the right. Right, and that's my delta x. Right, so those are my 2 directions I need to take to get from the point -2, 2 to the other point 4, -2. So if you noticed, I had to go downward in this example. So let's write my little reminder here of how to find slope. It's delta y over delta x. To take into account the fact that we're on the coordinate plane, what you'll actually notice here is that delta y traveled downward, right? So we did actually travel down, and then we traveled right. Well, on the coordinate axis, traveling downward on the y-axis is a negative direction. So my delta y in this case is actually negative. So this would be a -4 delta y over, and I'm traveling to the right again, that's positive direction on the x-axis, over 6. So what we would say is the slope of this line is -4 over 6, because to get from the 2 points I was given, we would go down 4 and right 6. A lot of times you'll be expected to simplify ratios if given, simplify your fractions, right? So to simplify -4/6, we can remind ourselves that if you can divide by a common factor, then you can simplify your fractions. 4 and 6 are both divisible by 2. So if I divide the top and the bottom of this expression by 2, then we get -2/3. And these two slopes are equivalent to each other, but -2/3 is a simplified ratio. Now, what if we didn't have a graph, right? Like what if you're expected to be able to find the slope of a line between 2 points where you don't have a graph? Can you find out the slope using some sort of mathematics, some kind of formula? And fortunately, there is a formula, and I'll go ahead and write it here. A lot of times you'll see this formula written as follows. M equals y2 minus y1, or you might say y sub 2 minus y sub 1. This is known as subscript, divided by x subscript 2 or x sub 2 or x2 minus x1. Now, what does that all mean? Well, when you have 2 points, what they're referring to in this formula here is the coordinates of your 2 points. When you see y2 minus y1, what they're saying is, what's the second y coordinate minus the first y coordinate? So going over here to the side of my graph, where my graph is, y2 would be this value, the -2, and y1 would be this value, 2, right? The second y coordinate and the first y coordinate. And then x2 minus x1 would be referring to the x coordinate of those points. So my second point was 4, -2, so the x2 would be 4, and x1 would be -2. So using this formula and color coding as I go, let me see if I can make this all look nice and organized for you. So y2 minus y1 would be -2 minus 2. Just like that, right? I have my minuses from the formula. So a -2 minus 2. And then my x2 is a 4, so 4 minus a -2. So hopefully you're comfortable with positives and negatives. Of course, you could use a calculator to try to help calculate this if allowed in your course you're taking. But here we go. -2 minus 2 is a -4. And 4 minus a -2 becomes plus. So that's actually, right, this is actually 4 plus 2, which is 6. And you can see we actually got the same exact slope as before, right? -4/6, which when we simplified it, we wrote that -2/3. Same exact slope, either by using the graph or using the formula of the slope, which I gave you right here. Lastly, I want to talk about 2 special cases. Let's look at and find the slope of a line that contains the 2 given points, -4, -5, and 2, -5. Well, just to help visually, let's go ahead and plot these points on the graph that I have on the right. All right, so visually, when you look at my graphs on the point, you might think to yourself, it looks like the 2 points are lined up horizontally, which means they don't have a delta y, there's only a delta x, right? So if I were to connect these points using a direction, it would only be a horizontal direction. And strangely enough, we don't have a delta y. So how would I write this using my slope formula where we know visually our delta y over delta x? Well, in this case, delta x would be 1, 2, 3, 4, 5, 6. But there's no delta y. So what that means is there was no change in the y coordinates, meaning you have a change of 0. There's no change in the y coordinates, so that's a 0 change. If you don't recall, 0 divided by any non-zero number is 0. And if you had to grab a calculator just to confirm, 0 divided by 6 is actually 0. We call this a 0 slope. Now, would I have found the same result by using the formulas before? Let me go ahead and write it. Okay, so let me correctly label my y2, y1, and x2, x1. y2, y1. So I'll write them over here, -5 and -5. I'm going to subtract them over another subtraction of my x2 minus my x1, and that'd be 2 minus a negative 4. And let's see what happens here. So on the top, we would have negative 5, and that would become plus. When you subtract a negative, that's known as adding. So negative 5 plus 5 is 0. And on the bottom, 2 minus a negative 4, this would actually be 2 plus 4, is 6. And we still have a slope of 0. So either by looking at a graph of the 2 points or using the slope formula, which is here, just to highlight it one more time. Lastly, let's find the slope of the line that contains the 2 given points, 1, 3, and 1, 0. So I'll start again with the graph. 1, 3 would be the point here, 1, 3, and 1, 0, right here. So now, rather than having only a delta x, hopefully it's obvious that we only have a delta y in this case. Let's go ahead and talk about delta y over delta x. We're going from 1, 3 to 1, 0. So technically you can say that you are traveling downward, right? To get from 1, 3 to 1, 0, you have a negative delta y. So that would be negative 3. But there is no delta x, meaning there's no change in the horizontal distance between the points. So that would be a change of 0. So we could just write delta x as 0. Now, hopefully you don't assume that we're running into the same situation as the previous example. What we actually have here is divide by 0. And any trustworthy calculator or math textbook would tell you that dividing by 0 results in what's called an undefined expression. This is undefined. And therefore, we call this an undefined slope. It is a flat line, but vertically, right? The line in between these 2 points would be traveling vertically, not horizontally. And just to confirm one more time, if we use the slope formula as shown before, y2 minus y1 over x2 minus x1, do we get the same result? And hopefully we do. So my y2 is 0, my y1 is 3, so 0 minus 3, and my x2 is 1, and my x1 is 1, so that's 1 minus 1. And what we get is a negative 3 over 0, and that still results in an undefined slope. I hope this helped you talk more about slope.